Okay, so last time we have discussed quantifier, okay, an example on it. Now today we are going to be discuss bounded and free variable. So if a quantifier is applied on variable x and the occurrence of a variable is bounded, then the variable is called bound variable. Okay, and occurrence of variable is not bounded by a quantifier is said to be a free variable. So now what it means, first of all, that we note down here, all x and there exists x are called the scope of quantifier. Now if we apply all x for some statement p of x, then it means x is bounded. If we apply there exists x on some p of x, okay, then it means x is bounded. Okay, like here consider some consider the following propositions: determine the bounded variable, free variable, and also the scope of quantifier. So this all x and there exists x, which we call scope of a quantifier. So here you have given one statement like for all x and p of x comma y. So here two variable functions in which we apply for all x, which we apply for all x. So x we call here bounded, x we call it bounded, and y is free variable, and scope of variable is all x. Okay, so I can write here, okay, so here x is solutions, here x is bounded variable and y is free variable. And scope, I can say that is all x. Now, so in second one, there exists x such that p of x implies q of x. Okay, there exists x such that p of x implies q of x. So here x is the only variable, x is only variable, and so scope what we have given, scope we have given here, there exists x only for p of x. Okay, so x is in, so which is apply for p of x only. Okay, there exists x for p of x. So statement p of x is bounded, q of x is a free statement, and there exists is x which is a scope. Okay, so I can say that solution here, scope as there exists x for only for p of x. Okay, not q of x. Okay, there exists x only for p of x. So this p of x statement is bounded. P of x statement is bounded. Bounded statement. And q of x is free statement. Okay, because there exists x which apply on p of x only. Okay. Now third one, that for all x in bracket p of x implies q of x implies not q of x, there exists y q of xy. So which is true for all x, and q of x implies there exists y such that q of xy. So q implies for such some y for that q of xy. Okay. So here in q of xy, x is free variable. Okay, in q of xy, x is free variable, and in general x is bounded variable. But in q of xy, x is free variable and y is bounded variable. And scope we have given for all x is for q of x and q of xy, and there exist y is for q of xy. So I can interpret it as here in q of xy, x is free variable. Okay. X is free variable and y is bounded variable. Okay. And in general x is bounded variable. Okay. So I can say that x is bounded variable for q of x and q of xy. As we apply here all x for this whole statement. So x is bounded for bounded variable p of x and q of xy. And scope here, scope of variable is for all x is for Q of x and Q of xy. And there exists a y for Q of xy, okay? So I hope so. This is clear for free variable and bounded variable for everyone. Okay. So we have discussed three example here for free and bounded variable and scope of the variable. Okay. So in first one, if here we have given statement for all x p of xy, so x is bounded variable and y is free variable and scope of variable is for all x. Similar manner in second statement there exists x which is for p of x and implies q of x. So there exists is scope here there exists only for p of x, and p of x is a bounded statement and q of x is a free statement here. Okay, and in third one for all x in bracket p of x implies there exists y such that q of xy. So in q of xy, x is free variable and y is bounded variable, and x is bounded variable for all. See here we have given for all x, this p of x implies there exists y such that q of xy. So this all x is a bounded x is bounded variable for this p of xy and q of xy. This is not small q, it is capital Q of xy. And scope of variable here for all x is for p of x and q of xy, and there exists y for q of xy. Okay, so is it clear for everyone? Okay, okay, fine. Now here, then we are going to be discuss uh, universal intent universals. Okay, next topic is universal intensiation. Okay, this. Now, universal intension, it is the rules of inference that indicate the truth of a properties in a particular case follow as a special instance of its more general or universal truth. So it is a rule of inference that indicate the truth of properties in a particular case. Okay, follow as a special instance of its more general or universal truth. Now, what it means, uh, like we have as p of x. Okay, for all x p of x. Okay, if I have for all x p of x, we have such that therefore p of c for some c, therefore p of c for some c. Okay, and where, okay, one thing I would like to discuss here, P of C, C is, okay, for some C of universe of discourse. Now, universe of discourse, it means which is the domain of a functions. Okay, universe of discourse, it means domain of a function. So this for all x, p of x, therefore p of c for some c of universe of discourse. So here p, which is a functions, and x is your variable, and x which are coming from universe of discourse. So for all x, p of x, therefore p of c for some c of universe of discourse. Okay, so which is true for some c in particular. So we call it universal intent CSM. Now second, essential, okay, second is universal generalizations. Universal generalizations, it means uh, it is true of, it is the rule of inference which state for all x p of x is true. Even the premise is that p of c is the true for all element of c of universe of discourse. Okay, so I can write as like p of x, here we have as a statement. Okay, and for all x p of x, all x p of x, okay, so x is not free variable in any given premises, so which is universal generalizations. Okay, which is true for not in particular for some c, but here for all x, which is true for all x, then we call it universal generalizations. So you have some statement p of x, and for all x p of x is true, then we call it universal generalizations. Okay, now essential specification, then another word is here exist existential. Existential specification. Okay, existential specification. Now, what it means? It is the rule which allow us to conclude that there is an element C in your universe of discourse. Okay, so in domain for which P of C is true, if we know there exists X, P of X is true. If we know there exists in P of X, which is true. So it is a rule which allow us to conclude that there is an element C in universe of discourse. There is an element in C in universe of discourse for which P of C is true. For which P of C is true, if we know that there exists X of P of X is true. Okay, so I can symbolically write here as existential specifications. There exists x p of x for which some c I get. In first one I get for all x p of x for which p of c is there exists, therefore p of c, and for there exists x p of x, therefore p of c. Okay, therefore p of c. So there is a difference between this universal intention and existential specifications. For universal intensifications, for all x p of x, therefore p of c, and here there exists x p of x, therefore p of c. Okay, we see some element for which p of x is true. Okay, now now essential generalizations. Existential generalization. So here P of C, okay, we have in particular some C. So therefore there exist P of X. So where C is some element of U of the universe of discourse. UOD it means universe of discourse, and universe of discourse it means domain. Okay, C is some element of domain. So we have a P of C, and therefore there exists X. There exists here X such that P of X. Okay, such that P of X. So we have some P of C for some C, which is an element of domain, and therefore there exists X such that P of X. So which we call existential generalizations. Okay, existential generalization. So it is the rules of inference which is used to conclude that there exists P of X is true when a particular element C of P of C is true is known. Okay, so these things which we have known, P of C which is true, and there exists some X, therefore such that P of X is true. So which we call is essential existential generalizations. So these four, uh, here we have start with this universal intentions, and then universal generalizations, universal existential specifications, and existential generalizations. So first one, for all x p of x, okay, for every element of a universe of discourse, therefore p of c for some C of domain, we get P of C is true. Okay, as we has known then, P of X is known for every X. P of X is true for every X, and therefore we get P of C is true for some C, which we call universal intensification. Then universal generalizations, we have P of X, and for all X, P of X. Okay, for all X, P of X, and so for all X, P of X is true. Okay, universal generalization. So So here x is not a free variable, and existential specifications and existential generalization. So these four. Okay, now for that I want to write the negations of quantified statements. Okay, now next one. First one, all x, there exists y, p of x y. Okay, so if I want to write the negation of this statement, what we can say here? For all x in bracket there exists y, p of x comma y. So now negation of given statement is for all x in bracket there exists y such that p of xy. Now, which is equivalent to what? Can anyone say which is equivalent to? Now, for all x, it means there exist x negations. In negations, I get there exist x. So first I get there exist x. Now in bracket. Now there exists y. So instead of there exists y, now I get all y. All y such that not p of xy. Okay, not p of x comma y. So this is the negations for a given statement. Is it clear? Okay, so here I have write the statement not all y in bracket there exists x such that p of xy or not all x uh, such that q of xy. Okay, for that, for all x for q of xy. So we want to find out the negation of this statement. So what I get here, which is equivalence to now negations of all y. I get all y. Okay, negations of all y, which I get all y. In previous, if I apply for negation on all x, then I get there exists x. But here we have already negations of all y. Okay, so negations of negations again, all y as it is, and in bracket there exists x p of xy. Okay, so here whole statement we have here negations. So negations will be cancelled out, and this all y such that there exists x p of xy as it is. Okay, there exists p of xy as it is. So these negations which apply on this for all y, there exists x p of xy. So negations I get as it is. So all y in bracket there exists p of xy. Now instead of 4, okay, if I apply this negation, so okay, first of all this, okay, so here we have negations for the whole statement. Okay, we have here not only this bracket, I forgot to write one bracket here. Actually, this is for this not for all y, which is applied for this whole statement. This for whole statement. So I have to write one bracket here. Okay. Now we have in this way, not all y in bracket there exists x such that p of xy or for all x p of xy. Now if we apply negations, then it is clearly that which is nothing but for all y there exists p of xy or for all x q of xy. So if I want to write the negations of this, okay, again here I have to correct this. Okay, first of all I have to correct this. Here I also require a bracket. Okay, so I get the statement itself. Okay, see, the only negations will be removed out. This all y uh, in bracket there exists x p of xy or all x q of xy as it is. So this is for all y there exists p of xy which is as it is in bracket. All y there exists p of xy. mm, and or sorry or for all x q of xy. Not here. Yeah, this all y which is applicable for the whole. So yeah, this is here or for all x p of q of xy for all x. So this negations for all y, which is applicable to the whole statement. So if I apply the negations again, then negations will be cancelled out and statement as it is. So these things which I have right here. Okay. Now third one. I have there exists y in bracket all x such that p of xy x comma y. Okay. And for all y q of xy. Okay, so for that you have to write the negations here. Reply in chat box. Okay, now there exists y. Okay. Again, I hear this. There exists y which is applicable to the whole statement. Okay, for whole statement. So I have to write this in here. These things in the bracket. Now write down the negations for this given statement. Okay. So try yourself and write down the negation for it. What you get here? See here we have given there exists a y. So in bracket for all x p of xy and for all y q of xy. So negations symbol and then I take the bracket in which I whatever we have given I want to find out the negation of it. Okay, so can anyone reply what we get here? Is equivalent to what?
सर वो एग्जिस्ट हुआ है
हाँ उसका क्या होगा? all y हो
सर
जाएगा.
एग्जिस्ट हुआ है यस सर ऑल हुआ है
Then exist y, for exist y I get all y. Okay, all y. And now in bracket what I get? Now instead of all x I get there exist x.
सर फॉर एक्स होगा या फॉर वाई होगा?
कहाँ पे? यहाँ पे for ये for
Yes,
all y, for all y, as we have given, see there exists y which is applicable to whole statement. Okay, now if I take the negation it means for all y. Okay, negations of there exists y I get all y. Okay, which I apply. See in previous we have a negations of negations, so which is already omitted and I get the statement itself. If I remove the negation, these negations which apply for all y for whole statements. Okay, previous one. So here negations of negations which will be cancelled out and I get the statement itself here in. But now here we have there exists y and which is there exists y which apply for whole statement here. Okay, and I want to take the negation. So first of all I get all y. Now in inner statement what I get now for all x I get there exists x such that p of xy. Okay, x comma y. Now instead of n I get or. Okay, instead of n now I get, if I apply the negations it means I get or. And now for all y instead of for all y there exists y. Okay, there exists y such that, okay, now this is not p of xy, not q of xy, in bracket not q of x. I have read there exists x.
सर negation
Yeah,
negation of pxy.
Yeah, negations of p of xy. I have to write this negations of p of xy. In similar manner here, there exists y,
or negation of
negation
q
of
of
q of
xy.
xy. Okay, negations of q of xy. Okay, so this is the negations of all statement. So now you get the clear in how to write down the negations if you have given this type of statement. Okay, by using quantifier. Okay, you scope of the variable, and if you have given a bounded or a free variable, then now you can easily write down the negations of this type of quantifier statement. Okay. Now remaining portions of this chapter is okay. Well, we have already discussed the argument. Okay, arguments which we have already discussed in PPT, like this. Okay, so remaining part now one lecture is remaining in this unit. We have to discuss the normal form and conjective normal form and the dejective normal form, which we are going to be discussing next sessions. And then after that we are going to be start the unit 3. Okay, so here I'm